All right, folks, let's go ahead and do this big race heat 3 for number 58. All right, so take a moment to read through there. Let's see. So you know how when we worked in class, we did heat 1, and the winner of heat 1 was, I believe it was Leslie. And then you guys did heat 2 on your own. Most of you guys did heat 2 on your own. And you should have gotten Elizabeth, who won heat 2. And those are the two gals who were participating in the final race today. But this is heat 3. This is a little side problem, right? So this one goes: Barbara, Mark, and Carlos participated in the third heat of the big race. Barbara thought she could win with a 3-meter head start, even though she only pedaled 3 meters every 2 seconds. Okay, so maybe you need to underline. Maybe you need to, jot down some notes, but I'm going to go ahead and underline. So I'll use red for Barbara. And Barbara is going to be 3-meter head start. So that's her y-intercept. That's where she starts. And her speed is 3 meters every 2 seconds. Okay, so that's Barbara. Mark, he began at the starting line, so he doesn't get a head start. He started at the starting line. Okay. And he finished the 20-meter race in 5 seconds. Wow, okay, so this one's a little different. So basically, this tells us that the race is 20 meters, and he did this in 5 seconds. So that's also very important. Okay, but that's also the end of Mark's race. So something to think about. And then with Carlos did, let's see, he rode tricycle so that his distance from the starting line in meters could be represented by this equation. Oh, cool. We have an equation for Carlos. Okay. So what are the dependent variable? What's the independent variable? So if you have a graph or you make one, right, the independent variable is this x unit, or it's along the x-axis. Okay, the independent variable is going to be your time. Okay, time is measured in seconds. Okay, and it's called independent because time, no matter what you do, time will keep moving, regardless of you stop or regardless if you're working on whatever, or just riding your tricycle. Time's going to keep moving whether you do it or not. Okay, your dependent variable is your distance. And distance depends on the time, right? If the time moves, then you can go the distance. If the time doesn't move, if there's no such thing as time, then you're stuck, right? You can't progress through your distance. So your independent variable is time measured in seconds, and your dependent variable is distance measured in meters. Okay, it's important to have these written down because sometimes they give you little hints as to how to proceed. Okay, so A, done. B, using the given information, graph the lines for Barbara, Mark, and Carlos on the same axis. Okay, so let's start with Barbara. She's in red, and she has a 3-meter head start, and she goes 3 meters every 2 seconds. So Barbara, she has a 3-meter head start, so right here is 3, and she goes 3 meters, so 1, 2, 3, and over 2 every 2 seconds. So Barbara basically does this over and over and over. So I'm not going to use the line. I'm just going to keep up with this rate. So up 3 over 2. Up 3 over 2. Up 3 over 2. Up 3 over 2. And the race is 20 meters, so up 3 over 2. Oops. I believe it was 20 meters, right? Let me read this again. Yeah, it's a 20-meter race. Right, 20-meter race. Okay, so that's Barbara. So once I have this kind of mapped out, plotted out, I can go ahead and draw my not so perfect line, and it's okay because my points are the perfect ones. Okay, Mark begins at the starting line, 20-meter race in 5 seconds. Oh, that's right. Mark begins at the starting line, and he does the 20-meter race in 5 seconds. So that's all we know about Mark. He begins there. he finishes there. So that's Mark. This is Barbara. Okay, and lastly we have Carlos. He's blue. He's gonna start at +1, so he starts at the 1 yard line or one meter line, and he goes up 5 meters for every 2 seconds. So Carlos, he gets a 1 meter head start, and he goes up 5 meters every 2 seconds. Okay, and we finish at 20 meters. So that's Carlos. Okay, so using given information, graph the lines for Barbara, Mark, and Carlos on the same set of axes. Who won? Right. So this one definitely Mark. Mark won. So I'm gonna put some stars around Mark. So Mark won. C. Write an equation that describes Barbara and Mark's motion. All right. So since Carlo already has an equation, okay. So Barbara, let's see. So Barbara would be y equals mx plus b. Right? And Barbara, she starts at the 3 on the y, so she has a 3 meter head start. So the b would be +3. And Barbara's speed or the slope. Barbara, it looks like she goes, and I'm going to just use one of the endpoints. So Barbara, it looks like she goes up 1, up 2, up 3, and over 2. So Barbara's speed is 3, or up 3, and over 2. So we're going to use 3/2 for Barbara. So Barbara's equation is 3/2 x plus 3. Here, I'll put it right here. Okay, Mark, he's green. So Mark would be y equals mx plus b again, just like how Barbara started out. Okay, Mark, it looks like his b, or he starts at 0. So you can say mx plus 0, or you could just leave it out. Okay, and Mark, we don't know what happens in between, but we do know he finishes 20 meters in 5 seconds. So our rate of change for Mark would be up 20 and over 5. Right, so change in y would be 20, and change in x would be 5. Right, so for Mark, his m would be up 20 and over 5. Okay, and 20 divided by 5, you probably know what that is, but that's going to be 4. So Mark's equation, you can leave as 20 over 5x plus 0, or if you want to make it even better, actually, you can rewrite it as a very simple y equals 4x. Okay, and you don't need to put plus 0. Okay, that's C. How fast did Carlos pedal? And so Carlos, he pedaled, and the speed is the slope. So 1, 2, 3, 4, 5 for every 1, 2. Right? And actually, it says it in his equation. Right? Carlos is 5 over 2, or Carlos, right? His speed. How fast did he pedal? Right? Carlos pedaled 5 feet, or 5 meters, excuse me, per 2 seconds. Okay. Unit rate. Okay. What's 5 divided by 2? Right. So 5 divided by 2 is 2.5. So his unit rate is 2.5, or 2.5 meters per second, per 1 second. Okay. When did Carlos pass Barbara? Confirm your answer. So Carlos, let's see, and Barbara. So it looks like Carlos and Barbara both met up right there at 2 seconds, and that was 6 meters. Right, so right here, we're talking about this point right here. Right here. Because you see Carlos in blue, Barbara in red, they both meet each other right there. Okay, my Barbara line is a little bit off, but right there. So they meet each other there at 2 seconds, 6 meters down the line. So it says when, the question, you got to read between the words, right? It says, when did Carlos pass Barbara, right? So Carlos passed Barbara at 2 seconds or after 2 seconds. Okay. To confirm this algebraically, right, that's the second part of the equation. We just got to set them equal to each other, the two equations, and we find out where that's equal to each other, and it should come out to be 2. So Carlos's equation is given up there in blue. Y equals 5 half x plus 1. So I've been putting in blue. So 5 half x plus 1. We don't need to put the y because we're going to be setting that equal to Barbara, whose equation is y equals, and we don't need to write y equals, but we need to write 3 halves x plus 3. And we need to solve this for x. So to solve it, we can go ahead and, let's see. Let's subtract 1. Okay, we will have 5 halves x equals 3 halves x. Oops. I meant that to be in red. Equals 3 halves x plus 2. Because 3 plus negative 1 is positive 2. And then we need to subtract the 3 half over. So minus 3 halves x. Okay, and that cancels. All right? And we should have equals 2 on the right-hand side. And 5 halves minus 3 half. Right? So basically 5 minus 3 because the bottoms are the same denominator. So 5 minus 3 is 2 halves x. And 2 divided by 2 is 1, so which means that we got 1x equals 2. Or just really x equals 2. Because we don't need to write 1 for 1x. So at 2 seconds. Right, and we saw that as well. This is at 2 seconds. Okay. Number 59. Just we got to circle the ones that are equivalent to 16x to the 8. I thought we were going to work each one out. Make sure you find all the correct answers. Okay. A is not it because A would actually be equal to 16 squared, which is 256. And that would be x to the 4 times 2 is 8. That would be correct, but the 16 would be wrong. So A is not it. Okay, this one right here, 8 times 2 is 16. X to the second, x to the 6 makes x to the 8 because you're adding those exponents, and that would actually work. So B would be true. C, so equal 2 to the 4th, and x to the second to the 4th, which is x to the 8. And 2 to the 4th is 2 times 2, 4, times 2, 8, times 2 is 16. So that'd be 16, and that'd be x to the 4th, which actually does work. So that one is also a solution. 4 squared is going to be 4 squared, and then x to the 4th to the second would be x to the 8 because you're multiplying them. And 4 squared is 16, x to the 8, and that actually also works. Okay. 2 to the 4th and 4, or x to the 4th to the 4th. Right? So 4 to the 4 is going to be x to the 16. Okay. Although 2 to the 4th, and we did that with C, that is equal to 16, but your x is also to the power of 16, which we want x to the power of 8 only. So that one does not work. So that one is not it. And the last one, you got 1/16 to the -1. Remember when we said you have a negative exponent, you got to move it to the other side. So this really comes out to be 1/16, and they each get -1. The x, -8 times -1 is +8. Okay, and remember when the base has a -1 or negative power, it goes to the other side, which means it's 1 to the 1 and becomes positive. 16 -1 means it goes to the other side and becomes positive. The x to the 8, that doesn't have a negative, so it stays put. And 16 to the first is just 16 divided by 1 is 16, and x to the 8. And that one actually works as well. Okay. And let's see the last one. Right, graph this equation. Right. So I'm just going to freehand. You can see how easy it is to freehand. Okay. You have to be aware of what you need to do, though. I do need to start at +9, so I need to go a little higher up. So I need to go have it a little heavier on the top. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, like that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 1, 2, 3. So just kind of just eyeball it. And again, like I said, if you know anything about equations, the equations of a line should start with y equals mx plus b, and the b is where you start. This is your y-intercept. Remember, this is also your zeroth term. That's just what happens at when x is 0, right? So the start is the 9, so we will have to start at +9. So you're going to put your first point at +9, and then this is your movement, right? This is how you move. Okay, move is your slope. This is your change in y over change in x, right? So this tells you how to move, and in this case it's just a -2, but we put because it's just not a fraction, we can make it into a fraction, so it's -2 over 1, which means that we're going to go down 2, because that's your change in y, and we're going to go to the right 1 time. So from this point right here, we're going to go down 2, and we're going to go to the right 1 time. Okay, and we can keep that pattern, so down 2, to the right 1 time. Down 2, to the right 1 time. And I think I have enough, but down 2, to the right 1 time. Okay, and you can just draw your line. You can graph your line.